for next payday.
You know why I don't have to.
Yeah, you spent it all at Wonderland. Eh?
I'll sum up another. I'll sum up a few.
Yeah.
Tomorrow's last day.
Yeah. Tomorrow's Thursday, so yeah, last day tomorrow. All right.
Free brand new car. You probably got the AirPod Max.
I'll just do attendance, or maybe I'll wait. I'll do attendance after the lesson. You guys remind me to do attendance after the lesson. All right. These clowns. All right, so welcome to all the kids that are watching from home. All the kids that went to Wonderland. I'm very disappointed in you. Sam, I am not disappointed in you. Isaac, also not disappointed in you for showing up. I know you guys rode the rides hard yesterday, and yet you're still here. Not like the rest of these quitters. All right, so our lesson today is on arithmetic series. And I think I've told you a little bit about, pardon me, these the other day. Somebody tell me what this reminds you of? What does the arithmetic series remind you of? No. Yes. Sure. Jane, can you go see this board? All right, so what does this remind y'all of? Something we did last week. Yeah? It does remind you of an arithmetic sequence. Athena. What looks different though? Exactly. There's an addition sign between every term. So you can't say it's a list of terms, but it's the sum of a list of terms. Make sense? So when you want to take the sum of a sequence, we call that a series. If the sequence happens to be arithmetic, you would call it an arithmetic series. If the sequence that you were adding all the terms of were geometric, you would call it a geometric series. And that's what we're going to do tomorrow, geometric series. So for today, we're doing the arithmetic series. Now, what might you be curious to know about this particular series or sequence that we're adding? Well, what type is it? We said it was arithmetic. What were the other things we considered when we were talking about types of sequences? Yeah? Now, is this finite or infinite? So it's a finite series. It's a finite sequence, and you're adding it to get your finite series. What might you be wondering about? Yes? Yes, you'd like to know the common difference. What else might be important to know? Yeah? How many terms exactly? So the n value, right? The n value for number of terms. No problem. Wrong number. I'm getting punked here. So, yes, both of those answers are perfect. We'd like to know the common difference, and we would like to know how many terms there are. How can we find the common difference? What are you thinking, Tristan? What does it look like we keep adding to the terms to get the next term? Yeah. And how did you get that? Yeah. Very good. So you just subtract one number from the number before it. So for example, he said you take 3 and subtract from it 1. That gives you 2. When you have an arithmetic sequence or series, this will always be the case. You'll have a common difference between two consecutive terms. So 7 minus 5 is 2. 9 minus 7 is 2. What's the term before 85 in this sequence or series? 83. So to find the common difference, you just need any two consecutive terms. You could even use two non-consecutive terms as long as you know what their term numbers are. So for example, if you wanted to use this, whoa, feeling like on a roller coaster. And by the way, the kids at home, yes, we looked at some videos of the Leviathan and Yukon Striker and all the rest of that. Talked about how enjoyable the day was. Okay, so you could also use two non-consecutive terms, but you'd have to make a little adjustment. So can somebody tell me what term 1 represents? T what? T1 or A, the letter A. Can anyone tell me what term that is? Holly, what do you think? If this is T1, what's this? T, no, T2 is 3. Do you understand what I'm saying? So, correct. Y'all get that? Okay, well, what would you get if you went T5 minus T1? You're trying to find the common difference, but you've gone a little overboard. Yeah, Sam? I think you do.
Well, I would say T4, but T4 is 7.
Well, you're close. The number 4 is relevant here. 4 times the number, but we don't call it the number. We say 4 times the common difference. How do you know it's 4 times the common difference? Because you used term 5 and term 1. Usually you use two consecutive terms, so you only get 1 times the common difference. Cool? So if we did that, if we went 9 minus 1, that should be 4 times the common difference. Well, 9 minus 1 is 8. And if you BS, the next step would be divide both sides by 4, which gives you D is equal to 2. So you don't have to use consecutive terms as long as you understand that you're looking at 4 times or whatever times the common difference. You can do the same thing with the common ratio, but you're not adding, so it would be a little bit, there'd be a little modification to that. Okay, so we found the common difference, and that wasn't too bad. We determined the common difference was 2. We would also like to know how many terms there are in the series. So how could we figure that out, guys? What are you thinking? I'll do the hard part. Tn equals. Okay, you do the easy part. There's a couple of things you could answer here that would be good. That's a good start, A. Yeah? Like this? I like that. Okay, let's try and make this a little more specific to what we've got here. So who wants to sub some stuff in? Any volunteers? What do you think, Domenico? Can you think of something I could replace A with? A means the first term. Do you see what the first term? So you're going to replace it with 1, correct? So that's going to be 1. We don't know what n is. Do we know the common difference? It is 2. Now, can anyone suggest something else that we could sub in? What do you think, Al? Do you mean the number 85? Yeah. Where would you sub that in? It's the last term, right? Where? No. We're trying to find n. To Tn. That's correct. Tn is the last term. So why don't we replace Tn with 85? Is that good? How many unknowns will we have after that? Exactly. So we'll be able to solve for it. So this is 85. And then we have 1. And then I'm going to write this as 2n minus 2. Do you see what I did there? Okay, what's your question, Mahat? Well, then you wouldn't be able to do this. So that's a good question. All right. So do we know what to do next? Solve it. So who wants to simplify the right side for me? Want to do it? Yeah. Just simplify what's on the right. Not to the 2n. Yeah? So what just happened there? So then you'd have 2n minus 1. Is that what you mean? And then what would you do? Add what to both sides? Good. 86 equals 2n. And then what would you do? Where? Ah. And then you get 43. So we just discovered that the series that we're talking about, the one that has the ellipsis in it, dot, 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 goes on until you get to the number 85. Well, we just figured out that there's a total of 43 terms in that series, which is going to be useful because now we can use it to find the sum. All right, I'm going to give you a hint because I would rather you not memorize the formula. I would rather you remember this hint. So, do you remember how you guys might have memorized the special triangles? Okay, so do you think it's easier to memorize those numbers, those arbitrary numbers, the square root of 2 and 1 and root 3 and all that? Or is it just better to remember the two triangles and then you can make the numbers up as you go? Well, we're going to do something similar. I'm going to tell you what the answer is. I haven't scrolled down. I'll use my calculator because I need it for just one simple calculation. Okay, the answer is 1,849. When you add all those numbers together, 1,849. Do you want to try it right now? Just go ahead and add the numbers. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Or do you want me to just show you the trick? Okay, well, you're doing well. Keep going. And I'll show you the trick in a second. Remind me we have to candle the eggs today. So that we're going to look at the eggs with a light to see the baby chicks, the embryos. You might be able to see the eye spots and blood vessels and might be able to see them moving around. That would be pretty cool, right? Did somebody write down the answer? 1,849? I'll write it here. Did you get it? It's too long, right? Nobody wants to do that. Nobody has time for that. You guys keep going. You're doing well. While you're doing that, I'm going to try and show you or give you a hint to what I did. No. Good guess, though. It is not. You got it? Nice. Way to stick with it, Sam. Okay, 85. Yes, it is, especially for a closer like you. That goes to Wonderland, takes care of business, shows up to work the next day, takes care of business. Respect. Okay, so what did I just write? Well, it's like I wrote the whole thing backwards, right? Okay. And what do you notice now? I didn't just write them. I actually paired them up, right? What do you see? Hey. Oh man, you're gonna be disappointed. Look at most of these kids that are missing went to Wonderland yesterday, and they should be here because I was in Wonderland yesterday, and he was in Wonderland, and so was he, and they're here, and they spent all this money in Wonderland yesterday, and their money should be in here. So tomorrow, we're on YouTube right now, so their kids at home should be watching. Bring your money for the cake auction tomorrow, kids. I don't want a trashy cake. I want the nice one. Let's go. Sure. Yeah, yeah. No problem. Yeah. There's nothing in it. Tomorrow. All right. So, what do you guys notice? What do you mean by there's a new sequence? Okay, no, you're not seeing it. There's a reason I drew a line below it. When you see a number, and a line below it, what do you think of doing with those two numbers? What? No. Adding or subtracting, right? When you add them, what do you get? What? 86, 86, 86? Yo! How many times do we get 86? We actually know how many times we get 86. No. No. We just did the work, yo. 43 times. We get 86 43 times. Guess what I did with my calculator? I multiplied 86 by 43, and then I did one other thing. Divided by 2. Why? Because I've got all the numbers twice, and I added them all. Now, do I need to write the whole list like that, or could I just figure this out with right there? I got it. I could figure it out right now. Because I know those two add up to 86, and then I multiply that by 43, and I divide by 2. Am I always going to multiply by 43? No, it's going to depend on how many terms are in the particular series you're dealing with, right? So that number can change. Am I always going to divide by 2? Yes, because I'm writing the list twice. So when I add all those numbers together, I'm getting twice the answer. So I've got to divide it by 2. So let me give you another example. And we'll come back to this in a second. All right, who wants to give me a list of numbers? Just make it arithmetic. Yeah? Okay, so, yeah, that's good. Now, you're going to go how far here? What do you want to make your last term? Okay, so if you want to make your last term 66, what you did is you added 5. Does that work? 60, 12, 13, 14. You got 14 terms there? Cool. So this is T14. This is T1. You all good? Now, you see I did that in my head using the same technique as we did earlier, because I know that I've got in 65, I've got 13 times 5. So I added the common difference 13 times to the first term. Now, I just need the first term and the last term to do the trick that we just did, right? So can somebody repeat the trick for us? What do you do? Whoa, whoa, 67, go. Whoa, nice. Do you guys know the 67? Hockey team? 67? You ever been to a game? Whoa, whoa! You ever heard that song? It's a 67 song. Okay, so what's going on? Who wants to tell me what's up? Go ahead, Sam.
You add those two, so you get 67.
Yep,
And you multiply it by 2.
yep,
And then divide that by 2.
yeah. So by 2, yeah, always by 2 because you've got 1 times the sum, all of those added together. And then when you write it backwards, it's all the same numbers again. So you've got the answer you want twice. You have to divide by 2. Do you understand? Okay, when I add the first term, which is 1, and the last term, what do I get? When I add the second term to the second last term, what am I going to get? So I know I'm going to get 67. How many times? 14 times. But you see, what I've done is I've added all these numbers once, twice. I just want the sum of the series, 1 time. But I kept adding the first and last, second last, second, third and third last, and so on. So the answer I'm going to get is double the answer I'm supposed to get. So you're going to have to divide by 2 every time. So you multiply by, that's n, and you divide by 2 every time. 67 represents what? The first term and the, because if you're not first, you're last. No. So you always take the first term and the last term, add them together, multiply by n, and divide by 2. That's it. Slick? What's up? Well, you tell me, what's 67 times 7? You're looking for what they all add up to. So in this case, you would be looking for hey, what's going on here? Change pages. So, you are trying to add all these together, okay? And the answer is whatever you just calculated. You're not doing it every second term. You're lining the series up with the same series backwards. That's correct, because they all add up to the same thing, right? Yeah. We good? So how do we write that? Well, this is the first term. What do we call the first term? T1. This is the last term. What do we call it? Well, be more general, because it's not always going to be 14 terms. Tn. So you take T1, and you add it to Tn, and then you multiply by n, and then and that right there is the sum of an arithmetic series. So here's the formula. Now, you might say, well, why are we calling it T1 and not the letter A? You're right. We can rewrite it with the letter A, and we're going to end up with something slightly different. So take this, replace it with A. If you're going to do that, what could you do with Tn? Remember, it's an arithmetic series, which is based on an arithmetic sequence. What can we replace Tn with in an arithmetic sequence? What's the general term? It's on the board still for arithmetic. A plus n s exactly. So you could replace this with A plus n minus 1 d. You guys understand that? And can you see that we could simplify that? What would it simplify to? 2a plus n minus 1 times d over n minus 2. And we could simplify that some more. 2a plus n times d minus d times n over 2. Well, it's not really necessary to keep simplifying it. This one right here is pretty good. But we could simplify it some more. And then it would involve, multiplying by n, and the n would cancel with this n. And anyway, this is the one that I would suggest you use, or the one with t1 plus tn, those two. So I've got them written here. So to find the equation for the sum of an arithmetic series, write the list forward, and below this, write the same series backwards. You understand I did that? In fact, you don't even need to do that. You just need to do it with the first term and the last term. And what do? We multiply that sum that we get by the number of terms, and we divide by 2. Because when you pair up the terms together, you're always going to get the same thing. So here's the first version. It's t1 plus tn, first term plus last term, multiplied by n, and then divided by 2. Cool? Or, if you want to replace t1 with the letter a, and then tn with the general term, then that gives you the second formula that's listed here. Slick? So that's basically it for today. So now you're able to find the sum of an arithmetic series. And like I said, this one here ends up being 1849. Ready to try one? Excuse me, ready to try one on your own? Let me see what we got here. Let me hide this. And find the sum of the first 10 terms. So, is this arithmetic or geometric? Arithmetic, you keep, what's the common difference? Okay, is it finite or infinite? If it's infinite, I can't ask you to find the series. But I can say, okay, maybe this is infinite, but maybe I'm only considering the first 100 terms. So then I'll say, find the sum of the first 100 terms of this sequence, or of this series. So in this case, I want you to find the sum of the first 10 terms. So go ahead and try that. And I'll get the eggs set up, and we'll candle them. Look at all those eggs. turn my camera on here, see if we can show some of the kids at home what's going on. All right. I guess I'll Google Meet it. Yeah. No, I didn't start a Google Meet. I don't know if anybody, can you tell if people are watching the stream? Okay. And, what's that? So what am I doing here? I'm trying to Google Meet and share my screen. So I'll share my camera. What? Of course. They're all right. Don't forget to smash the like button and subscribe, share a comment. Go to my Patreon. Okay, what am I doing? Google Meet. New meeting. Start instant meeting. All right. Use your camera. Yeah, let's allow that. Okay, I thought I just said allow. Yeah. All right, cool. So I'm going to turn the light off. And did you guys get your answer already? Should we finish that first? Okay. The camera's freezing. What's going on? Actually, we'll come back to it after. Now they get the camera. If you guys want to gather around, and then yeah, you can turn the light off. Better turn off the projector. Because that's a pretty bright light. Okay. And then yeah, great. So what we're looking for is you're looking for blood vessels, and you're looking for. Okay, so this egg, do you think it's developing? You see that really? You see the bottom part is empty-ish, and then at the top you see definite. That's the embryo, the chick. What? So if I move the light up, you can see the airspace at the top. Okay, and then that's where there's air being exchanged between the outside and the inside of the egg. But this is definitely developing. And then if I look for the name on it, oh, this was a blank. Nobody put their name on it. So somebody who didn't name an egg can always adopt that one there. So that one's good. Oh, this one's good too. That's another blank. We'll go through them all and see. So, does that look good? Yeah, definitely. That is JRC part 2. I don't know what JRC is. Okay, so this one here, you'll notice, I don't know if you guys can see the ring. There's a definite dark ring there. So that's called a blood ring. And that usually indicates that the eggs started development, but stopped. And that one is probably dead. It's dead? Probably dead. Ollie, can you go see Mr. Foster? Just put the little wedge in the door and close the light on the way up. All right, so where did we stop there? That last one was Cookie. Sorry.
Yeah, I guess.
Who's Cookie? Who's Cookie? Yeah, so that you can see that. Usually those are the blood vessels. You see them as kind of like a spider, like spider web network. This one's got a blood ring, so that one's probably, unfortunately, no longer developed. Some of them, they just do that. Now, I don't know if you can see the blood vessels or not. These green eggs are really hard to handle, but I feel like I can see some blood vessels, but it's hard to confirm with the green. So when we look at, say, a beige egg or a white egg, okay, so you don't see a blood ring, and then you see a dark spot. You guys see that? And can you see some blood vessels?
Yeah.
And then you could probably see the spot moving. Well, that's the embryo. That's the developing chick, and it's gonna start to go really quick after that. So if we check it in a week, the egg's gonna be almost full, you know, because the chick is occupying the space. You guys see that?
What's the name of it?
The name on that one is El Chapo. So El Chapo. Who's El Chapo?
That's probably Diego.
Diego, okay. So again, with the green eggs, it's hard to tell, but that looks good. Man, we're not gonna have that many, are we? It's gonna be crazy loud. And that one looks good too. So far, Cookie's the only one. Okay, so what do you think about this one here? You see how much of it is kind of like empty looking? So this is probably what we call a blank, where it's unfertilized. Not all the eggs will be fertile. So we've got, oh, which one was that? Rhea. Sorry, Rhea. Okay, what do you think of this one? Holy, it's so full. This might be, you could have twins, but there might be a blood ring on it too, so. Yeah. Well, you see at the bottom it looks darker in the band, but that might just be, you know, it's hard to tell if it's for real. It could be the embryo too. So that one we're not sure about. That is Colonel Sanders. Okay, what do you think there? That one's pretty obvious. There's nothing going on, right? So
What's the name on that?
So it's a blank. And that one is Uncle Mike. Who's Uncle Mike? Nobody here? Good. Good. Okay, that one's looking pretty good. Well, no, that one's not. I don't think it is a blood ring. If you look on this side, you see that dark spot and you see it moving. Yeah, so that's good.
So what's wrong with the
Oh, yeah.
Blood ring means it's usually like all the blood vessels have kind of collapsed down at the bottom, so they're not really circulating blood through the egg. So far we got, oh, this one is Luffy, Jeff. I don't know, Jeff. They're saying. And well, this one's kind of interesting because it doesn't look like it's a blank. It just looks like it's really slow, but you can see the embryo there. So I think that one's going, but it might be a little runt. Little dude. There's always smaller chicks, and sometimes they're fighters, and sometimes they'll be bullied. And okay, so this one's looking good too.
Where are we gonna keep all the chicks from the hatch?
Well, we'll put the enclosure in the back. There's all those pieces of plywood and this piece of plywood. There'll be like an enclosure with some heaters. This one's looking good too. Well, I'll tell you, we'll just track the ones that are blanks. So this one here, hard to tell. I think this one's a blank, but you never know. So this one's Arabi. Arabi? Okay. Arabi. It's hard to tell because there's a dark spot up here, so it might just be a little dude as well. Yeah. Okay, that's a blank. And this is, well, Henderson. No. I think it's a blank, but we can always adopt one of the dudes. Okay, so that one you see the blood vessels quite well, and that's looking good, right?
Oh, yeah.
And so
Is there one bird name on it?
yeah,
Might need to.
yeah. So there's two in the front here. That one was Tweety.
Oh, that's mine.
This one here, JJ.
Is it that?
No, JJ was good.
Oh, no, it's that.
JJ was the run.
Oh, I'm the one.
Yeah, JJ. Okay, so, oh, look at this guy, looking good. So we'll just go quick through these so they're not out of the, that one's Chloe. Sorry. always looking like a blank. This one's good. Good. Don't think we should blank. That one's a blank, probably. Napoleon. Who's Napoleon? Who is it? Yeah, so we're seeing a lot of these beiges. Reese looks like a blank. This one also. Steph Curry. Is that somebody in here? Oh, the beige one's Justine. Not looking blank, looking blank. So those ones there, the hens may not have got fertilized, you know. Didn't get the secret ingredient from one of the roosters. These ones are all looking good. The green eggs are looking awesome. No, just the hens that happened to lay those, they were definitely active with the roosters. They got down. Yeah. This one's good. All right. Oh, okay, so this one here, it's hard to tell. Let's see this one. Jaybird? Yeah, not sure about Jaybird. And, yep. Okay, that one's interesting. Maybe a little slower. I don't know what that means. Good. What was the interesting one? It's good. I gotta give you the name of this one. Pokanoosh?
That's mine.
Oh, so we're not sure. Pokanoosh? Not sure about Pokanoosh. Not sure about this one either. Is that Popeyes? Is that Chris? This one's good. And this one, not sure. It's Fernando. All right, so we got lots of chicks growing there, so we're excited. Candle one more time before. Candle one more time. So you guys all, if I didn't say the name of your egg, then it means it's developing, which is cool.
Yeah, I need to do that. Well, I never
Okay.
had an egg.
So what you're gonna do is you're just gonna write your name on. Where's the pencils?
No.
Man, I usually have pencils. I'm like, okay, grab a pencil and come and put your name on.
Alright.
So you two, Shageen, grab a pencil.
So I sharpen the pencil.
Oh, no. Good. So, but JJ the right. Just write the name you want.
Touch it with my other hands?
No. Have you, you got a dog?
I think I need to,
Okay. What are you doing?
There we go.
No, really?
Yeah.
We said Pokemon weren't sure though, right?
Yeah.
We said we weren't sure.
Don't
Don't give up.
I think
on
it'd be
it.
better if I said tender is 2.0.
Tenderer. Gotta be even more tender than tender. Tenderer. Yeah. Thunder tenderer. All right, so I'll put them back in the incubator and we'll candle them one more time. So what's gonna happen next week is on Friday to go on lockdown. See this yellow tray? Remember what the yellow tray does? Yeah, it spins. It's the turner. It just rocks them back and forth. So when you put them on lockdown, the eggs need to stop turning because the chick is going to start to break out of the egg, but they need the egg to be still so that they can figure out which way's up, and then they're going to crack the top. They're going to do like a ring, and then they'll pop out like a, they'll have like a hat. They'll carve their shell. But it's very difficult for them to pop out. Sometimes the chick is alive and it's trying to break out, but it runs out of energy and can't break out. So then it'll just die in
shell like that. So, but it's really hard. You want to help them get out, but at the same time, sometimes you do more damage than good, and you tear blood vessels and stuff, and then they end up dying anyway. So it's just better to leave them most of the time. What's that? Not come out? Yeah, you can have them if there's stuff. There's no egg to break out. It's still a lot of work for a baby to remember, but it's birth canal. So sometimes they'll do a C-section. All right, so I'm pretty pumped. And then you see all those pieces of wood? This is going to be their home. So it's going to be a square back here, about 4 feet by 4 feet, and then about this tall. And yeah, they're going to be in there with some eaters. So those are, and then when I bring them home, I usually use that cage. Because on the weekend, I don't leave them here. Because they need food and water and clean and stuff, so. All right, let me just end the blanks. What about them?
You eat the blanks?
Yeah, well, they've been heated for a while, so probably better not to eat them. But if you crack them, it will look like a normal egg. The blanks would. The ones that have started developing and died, the ones with the blood ring, and you crack them, you would see an embryo. And depending on how far along they were, it might look like a baby chick. Okay, where are we at? Arithmetic series. What did you guys get for the sum of the first 10 terms? 47? 245? So how did you get 245? What did you do? The first thing you have to do, yeah? Yeah, but how did you know what the last term is? You find the last term, so you found T10. What was T10? Everybody, so that's what you got. Okay, so you got T10. Now that you know, Jaheem, are you with us? Did you do the question? Oh, sorry. So you found T10, and you found it to be 243. So what are you going to do with the last term? Domenico, what are you going to do with the last term? You're going to add it with the first term, right? We're trying to add these numbers together. We want to add the first 10 numbers. Do you remember the little trick I did with you guys? What was it? Right. So when I say first 10 terms, well, you're going up to the 10th term, which y'all found to be 243. So if you were going to line them up backwards, who would you line up with the number 2? It would be the 40, no. Oh, the 10th term is 40, my apologies, sorry. 47, and yes, 47 would line up with 2. So you would say, okay, I'm going to have 47 lined up with 2. And then you might say, okay, you would line up 42 with 7, right? But you don't need to do that, because they're all going to add up to, the pairs are all going to add up to 49. So what do you do to find the sum of the first 10 terms? Well, you're going to take 49 multiplied by what number? 10. Domenico, you understand why 10? Okay, so you multiply by 10, and then you divide by 2. That's it. Cool? So you guys said 243 or 245? 245. Good. So well, you could do that, but it would be better. Like, it worked out well because it was 10, but it would be better if you did this. Go find a general term, pretend it's a sequence. Well, the sequence is A plus n minus 1 times D, and then you decide you want the 10th term. 10th term, first term, n minus 1, and then common difference is 5, right? So then solve for n. Sorry, not solve for n, solve for T10, because n is 10. So you got T10 equals 47.
Now you can do this part here. So double the first term, add n minus 1 times d, and divide by 2, and you get 245. Good? And what if we made it a little more difficult? Well, it's not that much more difficult, but look at part B. What would, instead of finding the 10th term, here they don't tell you how many terms there are, but is it finite or infinite? So what do you need to do? Yeah, figure out what n is for 130. Figure out how many terms you have. So do that, then find the sum, please. Okay? So it'll be basically, what do we got? Lockdown is next Friday for the eggs, right? Because it's 21 days, and we started the Monday of last week. So today is day 9, and then next Monday will be day 14. When we get to day 18, we take the turner out, and the eggs just sit there on the bottom of the incubator. Add some extra paper towels with humidity, and then you take the plugs out of the, there's vent plugs in the top of the incubator, and that's going to allow more oxygen in while the eggs are cracking out. You're going to see Monday and Tuesday are going to be pretty exciting because we're going to start to hear them cheeping, peeping, breaking out, and walking around inside there. But you got to let them warm up and dry out because their feathers are all wet. And then once they get dry and fluffy, you can take them out and put them in the enclosure, but they need to stay warm, so we have these brooders. And the brooders are heat lamps, and that little yellow, you see the thing behind Jaheen? On the ground there, there's a yellow square. So that thing has legs, and what it is the heating element. It's like a heat lamp, but it's not a lamp. It just keeps them warm, so they'll go hide underneath there, pretend that it's their mom sitting on them, keeping them warm. Those are called brooders. You guys stoked? You can hold the chicks. You're going to poop in your hands. You're going to bring them outside to the grass when it's warm outside. Let them run around a bit. See them start to flap their little wings. Learn to fly a little bit. All right. Did you guys figure out what 130, what term 130 is? 33rd term. Wow, that's crazy. So now, how are you going to find the sum? Yeah.
132 times 3.
Well, you're kind of taking a shortcut. You're memorizing a process.
No, you do a 130 plus 2.
Okay, 130 plus 2, right? First term plus the last term multiplied by
Multiplied by the
number of terms, and then divided by 2. Or just write the formula down the way you described it. What was your egg name? Yeah?
I just wrote my name.
Okay, so yours was good. It's not one of the blanks, so that's cool. Are you guys done? Did you find the sum? What was your answer?
2007.
You guys get that? 2,178. So it should be 132 times 133 divided by 2. Right? 33? Yeah, so 132 times 33 divided by 2. And $33 over 2. The first term was 2. The last term was 131. Is that right? 131? No, 130. So what was the number again? Sam? What was the number again?
That one term?
The total.
Oh, yeah, 178.
8. Did you get it? Yeah. Did you get it? So we're good? This is nice and easy? Say that again? Oh, they've all been easy. You just gotta listen for the hints and... Alright, so that'll be the end of the stream for today. Anybody on there? Oh, I still got the camera instead of the... That's... Oh no, it shouldn't be on the camera. That's weird. Oh, it's showing the old stuff. Alright. Is my Google Meet still going? Because it told me it ended. Whatever.
I'm on live right now.
Alright, so I'm going to end the stream now, because... What's it showing now? The screen, or
It's showing
not the camera anymore? Okay. So we're going to end the stream and post the video.